we should be on, with your yellow notes, we're starting a new chapter, chapter 3. We're moving into a new unit as well. We're moving into our algebra unit. So in order to do that, we're going to start with expressions. So there's a difference between expressions and equations. Equations have equal signs and expressions do not. So we're not necessarily solving or finding the value of something in an expression. When we're working expressions, we're simplifying those expressions. Well, how do I simplify an expression? I have to combine like terms, and I have to get rid of parentheses. Okay, and that's what we're going to talk about today. We're going to talk about combining like terms. Now, last year, you did combining like terms. I don't know if you remember or not. In my class, we did algebra tiles, and we put all the green tiles together and all the red tiles together and all that good stuff. This year, we're still going to be doing the same exact thing. So in an algebraic expression, we have like terms. In order for something to be considered a like term, the terms have to have the same variables, and those variables have to have the same exponents. So we have to have same variables, same exponents. Say that with me. Same variables, same variables, same exponents. Y'all are same variables, y'all are same exponents. And I point to you, straight apart. Ready? 1, 2, 3.
Same variables. Same mark.
Y'all are terrible, and y'all are the cheerleaders. Ready? And 1, 2, 3.
Same variables. Same part.
Same exponent.
You're on the R side too.
Alright, so let's try it again. Same variables.
Same variables.
Same exponent.
Same exponent. Same variables. Same exponent. Same variables. Same exponent. Same variables. Same exponent. Same variables. Same exponent. Same exponent. Same variables. Same exponent. Same variables. Same exponent. Same variables.
Alright, so what do you have to have in order to have like terms?
Same variables.
Same variables
Same.
and same exponents. That's very important to remember. Okay, constants are also considered like terms. Alright, so we have to remember the different pieces or we're going to get confused. So this should be a quick review of this vocabulary that we talked about and discussed last year. If I take my red colored pencil and I either shade over or box in the word variables, your variables are your letters. Do we know what our letters are worth? No, that's why they're unknown. So if we look in the expression 3x plus 4, which one of that is the variable?
4.
Variables are
Oh,
the
the variable.
letters, so your x is the variable. Okay. Then we have our constants, and your constants stand alone. They're constantly all by themselves. And because they're all by themselves, they're unchanging.
Yeah, I have it too. Which one that Mr. told us?
Okay? They are, the thing about constants is they are what they are. They do not change. It is what it is. So in the expression 3x plus 4, which ones are the constants?
3 and 4.
4. Just the 4 because the constant, yep, constants stand all by themselves. They're all alone. It doesn't matter what happens in the expression. The 4 is always going to be a 4. It cannot change. It has to stay a 4. Nothing is ever going to change about that. Then we have your coefficients. The prefix co means with. Means it's with something. The coefficient is the number in front of the variable. And the operation that's happening between that number and variable is it's being multiplied. Notice it just said the number in front. It didn't say number and variable. So which part of our expression 3x plus 4 is the coefficient? 3. Not the x, not the 4, just the 3. That's our coefficient. Alright, so looking at example 1, we want to identify the terms and the like terms in the expressions. So we're going to use colors to help us identify which ones are the same. So I'm going to start with red, so everybody get your red colored pencil. Okay? The thing about like terms, you have to take the sign in front with it. It's no longer just 2. It's minus 2 or plus 7 or minus x. So the thing is, what about the very first term? That 9x. It's got a sign, it's just invisible. What can our sign be? Positive. So we're going to rewrite this as positive 9x. Here, let me use black, sorry. Use your black to rewrite it, or use your pencil to rewrite it. Positive 9x minus 2 plus 7 minus x. What are the requirements for them to be able to go together? What do they have to have? There's 2 requirements. We just did a cheer that y'all failed at. Same variable, same exponents. Same variable, same exponents. Okay. Do we have any exponents here attached to our variable? No. We actually have some. They're just invisible and you don't see them. Okay? So there's actually an invisible one right there. So we're going to go ahead and give it the invisible 1.
Oh yeah, I knew that.
Because anything raised to the power of 1 is just itself. Okay? So there's an invisible 1 right there. Now, we can take our red, and I always start with the very first term. So I have positive x to the first power. Do I have any other terms that have x to the first power here? What do I have? The last one, minus x to the first power. Is there anything else that can go with those 2 things?
No.
No. So it's like we're going to sort these, and we're going to drag these over to the second bucket over here, and now I've got plus 9x to the first power minus x to the first power. Okay? We got 9x minus x.
We got that one, please.
Okay? Then I'm going to go, okay, well there's nothing else that I can circle red, so I'm going to go to the next term. I've got minus 2. What can we combine with minus 2? It's a constant, so all constants can go together. Do I have any other constants? Plus 7. Your constants are like terms. So these 2 things can go together. So I have minus 2 plus 7. Alright. Now that they're sorted, we can combine them. We can simplify them. So I have 9 x's, take away an x. So how many x's is that? I have 8 x's. Alright?
Is this one just what I write here?
And then I have negative 2 plus 7. Well, I can plug that straight in my calculator. What's negative 2 plus 7? Thank you for saying positive. Positive 5. Whatever my sign ends up being, that's the operation sign between it. Now I can put these two things together, and it's going to give me 8x plus 5. Can these two things go together? Can these two terms? Can 8x plus 5 be put together? No. Why not?
Because one has a variable.
One has a variable and one's a constant. Are those the same?
No,
So they can't go. Okay? So let's look at B. So we'll start with my red. Well, before I start with my red, I need to probably do some rewriting here. Okay? I need a positive in front of my Z. Alright, this has exponent. This first term has an exponent and the third term has an exponent. What's the exponent of the second term? It's invisible, so it's just a 1 and a 1. Okay? I'm going to start with my first term. So I have plus z squared. Do I have anything else that can go with z squared? I'm looking for a z and a 2. What can go with the z and the 2?
It's minus.
But you got to include the sign in front. That's going to be your biggest mistake. You're going to forget to take the sign. So minus 3z2. Alright, can anything else go with those terms? Candy, can anything else go with them? Fry. Nothing. Why?
None of them are
Okay, they have the same variable, but what else do they also have to have the same of?
exponent.
Exponent.
So
Just because this is a z, does it share the same exponent? No. So can it go with these two terms? No, because they have different exponents. So these two things can go together. So plus z squared minus 3z squared. Okay? Now I have z to the first power. Do I have any more z's to the first power?
Yes.
Okay? The very last one, right?
Yes.
Those things can go together. So I've got plus 5z to the first power plus z to the first power. Okay, so here I have a z squared and I'm taking 3 z squares away. So it's like I have one zebra, take 3 zebras away. So what would that be? One zebra, take away 3 zebras would be, I would put it in my calculator if I didn't know. How many zebras are right here? Look right here. Just one. Okay. So what's 1 take away 3? So negative 2 z squared. Then over here I have 5. What can go in front since we don't have a number right there? What can go right there? An invisible 1. So I have 5 and 1, which gives me 6z.
And you gotta put positive sign.
And it's positive.
And you gotta put
Can I combine these two things right here? Can I combine those two terms?
No,
Why?
because the last one doesn't have exponents.
Doesn't have the same exponents, okay? This is an exponent of 2 and this is an exponent of 1. And is that the same? No. So can we put it together? No. So this is as simplified as it can go. Alright, try it for 1, 2, and 3. I just want you to circle, using your colors, the like terms. Okay, we're not going to simplify them. I just want you to identify the like terms by circling them, using your colors. I'll give you 2 minutes. All three of them. Blaine, have you already done this?
No, I'm trying to figure it out.
If you had to sort them into different buckets,
It's will still be available.
you have to have a variable and an exponent. Alright, so let's look at this. Let's especially starting with number 2. Okay? Let's look at number 2 is kind of, okay, it is a little iffy. I always start by doctoring it up, making sure everything has an exponent, everything has a sign. So I'm going to put a sign up at the front. That variable has an exponent. Does this variable have an exponent written? No, it's invisible. So what is it if it's invisible?
It's a 1.
It's a 1. Alright, and then that has one. The constant, it doesn't need an exponent. Only your variables need an exponent. The 2 criteria. It has to have the same variable and it has to have the same constant. So what are we looking for the red? What variable are we looking for? R. What exponent are we looking for? 2. So I come here. Do I have an R? Yes. Is the exponent a 2? Look in here.
I was not.
No, we weren't looking, were we? We have an R, but is our exponent a 2? Just answer my question.
No.
No. So can it go with the red? No. So I'm going to keep moving. Alright, I'm going to come here. Does it have an R?
Yeah.
Yes. Does it have an exponent of 2? Yes. So then it'll work. Okay? And then I come to the next term. Does it have an R?
No.
So then I just stop right there. Okay? Now I'm going to change groups. Alright? I have an R and I have an exponent of 1. Will my 9 go with that? No. Why will my 9 not go with it? Okay? It doesn't have a variable. So it's a constant, it can't go. So it's in another category. Okay? Number 1. Jerry, what did you put together in number 1? Okay? So she put the Y yo-yo and the -3/2 yo-yo together. And then she put the +10 separately. Did you do yours this way? Yes, you should have. That's the correct way to do it. All right, number 3. If I start with 7, what else can go with 7, Elias?
7, 5.
Not just the 5, though. You got to take the sign with it.
Miss Pittman, will you send Jariah to the office?
Yes, ma'am.
Okay.
So you got to take that sign. You got to take that -5. Okay? Can anything else go with that 7 and that -5? No. Okay? I've got plus 4p. Elias, what else can go with my 4p?
Is that plus 2Q?
Yep.
Plus 2Q.
Alright. Is your P and your Q the same? No. Think about it for a second. Think about it. The P is for pigs, the Q is for quail. Are pigs and quails the same thing? No. So can we put those together? Can we put them in the same box? If I'm selling pigs and I put pigs and quails, can I put them in the same box? No. They're separate. They're different things. You can't go together. Do I have any more pigs that can go with the 4 pigs? What about the 1 pig right there, guys? Wake up.
Because you don't need to.
Alright, and then your quails, they're all by themselves. They have to have what to be able to go together? Same variable, same exponent. If you're not going to give 2 cents to care, then I don't know why you're here. Y'all acting like you half asleep. I'm trying to make it entertaining and you don't care. Hurts my feelings. Real bad.
I care.
Alright. An algebraic expression in simplest form. When it has no like terms and no parentheses. That's what we're getting rid of. We're getting rid of like terms and parentheses. You can't stop until this is done. Look at example A. I have 6 Nutellas and I'm taking 10 Nutellas away. How many Nutellas do I have?
4. Negative.
I have 6 Nutellas and I take 10 away. It's going to be
Oh, negative.
negative 4 Nutellas. Can I put those two things together? Yes. Why was I able to combine those? They're the same thing. It's a Nutella and a Nutella. Guess what? They go in the same box. Alright? In example B, I have negative 8.5 watermelons plus 5.2 watermelons. How many watermelons is this right here? 1 watermelon. So how many watermelons do I have? Can I put all those watermelons in the same box? Yes. Why am I able to put all the watermelons in the box?
Because they're all watermelon.
They're all watermelons. They're all the same. I can put them together. So solve that. Negative 8.5 plus 5.2 plus 1 gives me how many watermelons? Negative 2.3 watermelons. Okay? Alright, we're going to wait there. We'll finish up tomorrow. Go ahead and pack it up, clean it up.